Hey guys, Mr. McKinney here, just doing our second video on position, velocity, and acceleration. In this one, we're going to look at a horizontal motion example. So let's think about this Ewok that's moving along a log so that its position at any time greater than 0 is modeled by this function. So again, S is measured in feet. Since it's measured in feet and it tells us that it's a position function, this original function is our position. If we want to find the velocity, that's going to be the first derivative. If we want to find the acceleration, it's going to be the second derivative. So let's look at the types of questions you can answer with this information. Find the displacement of the Ewok during the first 2 seconds. Displacement just means how far away from where we started. It doesn't actually tell you how far you traveled, because if I start here, if I start at point A and I go to point B, displacement doesn't care how I get there. So I might go straight there, I might go there and come back, I might take a really weird wobbly path. So displacement is just how far away from where we started. It doesn't care how we get there. So during the first 2 seconds to find the displacement, I just want to look at where I am when I start and where I am after 2 seconds and compare those two distances. So S of 0 would be 0 squared minus 4 times 0 plus 3, so 3. And then S of 2 would be 2 squared minus 4 times 2 plus 3, so 4 minus 8 plus 3, negative 4. Negative 4 plus 3 would be negative 1. So displacement means the distance between those two, where I started and where I finished. Now on this particular problem, we started at positive 3. We started at positive 3, and then we moved back to negative 1. So my displacement would be 4 feet. I've moved 4 feet from where I started. And we would say that the displacement in this case is a negative 4 feet, because we would do S of 2 minus S of 0. So in this case, we would say negative 1 minus 3, which would be negative 4 feet. So again, displacement is just how far away are you from where you started. The total distance we're going to calculate later on in the course when we start dealing with integrals. Displacement just means how far away are you from where you started. All right, average velocity. Anytime we see average velocity, remember that we need to do a slope calculation, because we're just doing the slope of the secant line. So during the first 4 seconds, we just need to look at 2 points. We need to look at when t is 0 seconds and when t is 4 seconds. So I like to just make myself a little XY chart, or in this case, a t, S of t chart. So when t is 0 or when t is 4. If I plug in 0, 0, 0, I get 3. We already knew that one. If I plug in 4, 4 squared minus 4 times 4 plus 3, 16 minus 16 is just 3. So average velocity, I need to show a slope calculation. So S of 4 minus S of 0 over 4 minus 0. Make sure you show 4 minus 0. Even though you can do that in your head and the answer is 4, you need to show that. So now when I plug these numbers in, S of 0 was 3, S of 4 is also 3, so 3 minus 3 over 4 minus 0 would be 0 over 4, which is 0 feet per second. So the average velocity would have been 0 feet per second. He wasn't stationary the whole time, he was moving, but average velocity, you just look at the slope of the secant line, so you just take those 2 points. Make sure you show your slope calculation. As long as you showed the slope calculation and you didn't skip any steps, you should be fine. And when I say skip steps, I mean make sure you show 4 minus 0, even though you can do it in your head. All right, find the velocity of the Ewok at 4 seconds. If you don't see the word average, you're going to assume that it's the instantaneous velocity. So if I want to know the velocity at any given time, I can just take the derivative of my position equation. So the derivative of position is my velocity. In this case, it would be 2t minus 4. So I want to know the velocity at 4 seconds. That's a t value. So I'm going to say, what is v of 4? So 2 times 4 minus 4, 8 minus 4. So v of 4 would be 4. We're dealing with the velocity, so it's 4 feet per second. So the velocity of the Ewok at 4 seconds is 4 feet per second. All right, acceleration. So acceleration is going to be the second derivative of position or the first derivative of velocity. So we said that the velocity equation was 2t minus 4. If I take the derivative again, the acceleration equation is going to be 2. Note that the variable has gone away, so 2 is a constant. My acceleration in this problem is constant. So it doesn't really matter when, at 4 seconds, at 10 seconds, at 3 seconds, the acceleration is always 2. So 2, when we're dealing with acceleration, the units are going to be time squared. So in this case, 2 feet per second squared. All right. Describe the motion of the Ewok. At what time does the Ewok change direction? So when you change direction, you're going to be looking for a sign change in velocity. So let's look at the velocity equation. V of t would be 2t minus 4. We want to know when there's a sign change, and there's going to be a sign change when it's equal to 0. So we want to make sure or find out when v of t is equal to 0. So 2t minus 4 is equal to 0, 2t is equal to 4, t is equal to 2. 2 seconds is when the velocity is equal to 0. So let's make ourselves this is called a sign chart. And in this one, we're going to compare the time versus the velocity. So when the time was 2 seconds, the velocity is 0. So we want to look at a time before 2 seconds and a time that's after 2 seconds. And we want to, really all we need to know is the velocity positive or negative before or after. So let's plug in a number less than 2, like 1. So if I plug in 1, v of 1 would be 2 times 1 minus 4, which would be negative 2. Now when I'm making a sign chart, I don't have to put in all the actual values. I just need to show whether it's positive or negative. And then I can look at like v of 3, so 2 times 3 minus 4 would be a positive 2. So this is the information that I would want to show on the AP exam to help justify my answer. So I'd make this sign chart, and then I would explain what happened here. So I would say the Ewok was moving left until 2 seconds, and then he turned around and started going right. I know this is hard to read. So Ewok was moving left, negative velocity, until 2 seconds. He turned around and started moving right after that. The important thing that you're going to want to remember in calculus moving forward is that you're looking for a sign change in the derivative. In this case, velocity is the derivative of position, but that's going to come up over and over and over and over again. You're looking for a sign change in the derivative. In this case, the derivative was velocity, and we were looking for where it went from negative to positive. All right, let's look at a little bit more complicated version of this example. So this Ewok is captured, and he's flown off the planet, and his motion can be modeled by 2 separate equations. One modeling his x, so that's his horizontal position. One modeling his y, so that's his vertical position. And both of these equations are functions of time. Now, we want to know what is the rate of change of the vertical direction with respect to the horizontal direction. Both of these, I could take the derivative and it would tell me not the rate of change with vertical with respect to horizontal, but I could find the rate of change of vertical with respect to time or horizontal with respect to time. But if I want to find the rate of change of vertical with respect to horizontal, I would have to set it up like this. I want dy dx, and I'm going to set that up as a fraction of dy dt divided by dx dt. So this is the rate of y with respect to time This is the rate of x with respect to time. And you can set up that fraction to find the rate of y with respect to the rate of x. On this particular problem, the derivative of y with respect to t, so y prime of t would be 2. And then the derivative of x with respect to time, x prime of t would be 6t squared minus 4t plus 1. 6t squared plus 4t plus 1. Sorry, not plus 4t, that's a minus. So if I wanted to know the rate of change of y with respect to x, I can set up dy dt over dx dt. That's if my equations are in terms of time, not in terms of each other. If I just have an equation of y in terms of x, then dy dx is just the derivative. But if I want dy dx and both the equations are in terms of t, I would have to set up dy dt over dx dt. And we're going to get into different variables a lot more in the coming units. All right, hope this helped.